All right, we're back now. Because of the large number that I have here, I've changed a find yx when x equals 2, not 5. You put 5 in there, you get a huge number. So we're going to look at this equation here, plus this equation here, I'm sorry. And we're going to put wherever I see x, I'm going to put 2. 2 squared minus 1 plus 210 minus 6. That's e to the 4 minus 1 plus 210 minus 6 equals e to the third plus 210 minus 6. E to the third is 20.1 plus 210 minus 6, and my answer is 230.7. If that's revenue, that would be in dollars. So, once again, if I didn't have the constant, I didn't have this, I'd get 20.1 plus C. I cannot do anything with that, okay? So I have to know the constant. And that's the way, in order to know the constant, you need additional information. And I'm going to show you some other thing about the constant, too. Give you a little bit of time to write this down, although you can go over it. I know the nice thing about the video is you can go over it. Okay, let me erase just this part. And let me just give you some heads up here. Oops, there goes my, okay. Okay, so let's talk about some practical stuff. Suppose you have a function r of x equals 3x squared plus 2x plus c. Okay, you want to find C. And suppose they give you no other information. So if they give you no other information, this is only for revenue, then you can assume that R0 equals 0. What would that be here? R0 would be 3 0 squared plus 2 times 0 plus C. So C would equal 0 here. So our function would simply be what it was before without the C. That would be the complete function. There'd be no constant. Now let's look at another one just for completeness sake. Suppose I have this revenue function. I have this revenue function. I have Rx equals x squared minus 10 to the squared plus C. Now, I'm not given any information. This only holds for Rx, only holds for revenue. Of course, you need some information. Only holds for revenue. Okay, so I would assume that R of 0 equals 0. So let's put R of 0 in here. So R of 0 equals 0 equals 0 squared minus 10 squared plus C. So we have 0 equals 100 plus C. So what does C come out to be? C comes out to be minus 100. So the revenue comes out to be x squared minus 10 squared plus minus 100. And let's give another example. Suppose I'm given for this function for Rx equals x squared minus 10 plus C. Suppose I'm given that R at 0 equals 500. Well, that would mean I would set that equal to 0 squared minus 10 squared plus C. So 500 would equal 100 plus C, so C would equal to 400. So in this case, R of x, the complete function, is going to be equal to x squared minus 10 squared plus 400. Now here, you would have to be given something. Here, nothing is given about R0. So that you always assume that R0 equals 0. But if you're given something, then you have to put down what they give you. And this is 500. So the function changes. Here it's just x squared minus 10 minus 100. Here it's x squared minus 10 squared plus 400. So that's for revenue only. Cost, you will always be given something, because there's always a fixed cost involved with anything you do. All right, I'm going to give you a you-do problem, and I will go over this on Wednesday. So this is a you-do problem, and this is taken. There is always a problem like this on the final. Once again, there is always a problem like this since I've been teaching here. So this example is a you-do, and there is always a similar problem on the final exam. What does that mean? That means that I will review this. So let me give you the problem. I am given, for a company, the marginal revenue, remember this is dr dx, equals 3x. I'm aiming that the marginal costs equals 3, the square root of x plus 4. Okay, so what do I want to find here? Find A, the revenue function, the ravine function. That one is in a ravine and you can't get it. So the revenue function, integration, B, the cost function, integration, C, the profit function, subtraction, D, find the profit when x equals x equals 5, and E, find the value of x that maximizes the profit. Now, suppose you can't find a value of x that maximizes the profit. Well, then you have a really weird function, but that can happen. In fact, it happens here. I'll give you a little heads up. And you're also given the fixed costs. So C of 0 equals $50. And you're given nothing about the revenue. They don't give you anything about the revenue. So once again, you're given fixed costs, but you're given no information about the revenue function. So what do you do then? Therefore, you assume that when x equals 0, R0 equals 0. You're not given anything, you always assume that. And that's true in this function too. Okay, so I want you to try that. revenue function, the cost function, the profit function. Find the profit when x equals 5. Find the value of x to maximize this profit. Set the derivative equals 0. Find the x and find out if that x is a max or a min. You're going to find out that there's no maximum here. I'll give you a little heads up. So I'm going to go over this Wednesday. So this is something for you to do. I'll give you time to copy it down. All right. And we're about to enter the magical world of definite integrals. Okay. So let's get this off the board now. If you don't have it down, I know you can always go through it again. And now we're going to enter chapter 13. And we're going to do 13.2. I'm skipping the area under the curve for now. I'm going to do one example on it, but not right now. Now, your homework assignments are on Google Docs in your files, but I'll put them down here. 13.1, and these aren't much, but they are long problems. Okay, 13.2, I'm sorry. This is from the worksheet of 12 and 13. So this is number 31. A to J. And 32 to 41. 12.3, just two of them, just that we don't cover a lot in there. And this is 45 to 48. And that ends your assignments for the term. Okay. The second thing I want to do is I want to do a comparison chart. And here's what I'm going to have here. I'm going to have the indefinite integral, and I'm going to have the definite integral. What's the matter?
Okay. I got a minute and a half or so.
Okay, it's all right.
Yep.
This is the second part of this class, right?
Correct.
Yeah, so we have another card to go. Good. Okay. So I'm going to take the same example here. I'm going to be given, in this case, I'm given y equals 300x. No, I'm sorry, I'm given dy dx equals 300 minus 0.2x. Same thing here. Now, none of the integration rules change, just the procedure changes. So I want to find y. Okay, here I want to find y. Okay, find y between two x values. So it's between the values of 500 Now notice I don't specify any numbers here.
I'll wrap this one up.
Okay, and we'll come back